Welcome to video number 6. Welcome to video number 6. Okay, we're getting close to done. We're page 18 and 26. Not going. This has been too bad. The figure above gives the graphs of four functions labeled A, B, C, and D on the xy plane, which is the graph of 2 inverse cosine of x. So this right here is a vertical stretch. So this should be an extended stretch from, so the normal domain, the normal range for this is, the normal range for cosine. So vertical is going to be a range stretch, vertical. So the normal range is from, it only outputs values from 0 to 2 pi, not 2 pi, 2 pi, quadrants 1 and 2. And if I stretch it, I am stretching it by doubling it. So this should now, I'm doubling the distance. So it should be now from 0 all the way to 2 pi because of this stretch. So anything that gives me from 0 to 2 pi. So this should be whichever one this one is, which looks like C. 30. The function f is given by this, okay, and that's our restricted domain for sine. So they're probably going to invert it. What is the domain and range for the inverse function of f? So our domain is, so that's our domain right now. So this should swap and become our range. So our range should be from negative pi over 2 to pi over 2. That should be our range, because this was our domain. When we invert it, we swap x and y. We flip the domain to become the range. So this is good, this is good. Not this one, and not this one. Now, the range of sine is just the minimum to the maximum. So the range of our original one, the minimum is going to be your vertical shift, which is 0, minus 1/2. So our minimum is negative 1/2. Our maximum is 0 plus our midline, which is 0, plus our amplitude, which is positive 1/2. So that is the range of sine. So this becomes our domain of inverse. So which one of these is negative 1/2 to 1/2? It's got to be A. So in this case, find the domain and the range of sine and then swap them. 31. The function p is given by p of 0 equals 3 tangent of, so all of that. So there is a phase shift, which is annoying to work with. Maybe we'll see what happens. Vertical shift, there is a period change, and there is an amplitude. What is the period of p? Oh, just the period. Well, the normal period of tangent is pi. Therefore, the period is going to be pi over b instead of 2 pi over b. So this is going to be pi over, b is pi over 2. Keep, change, flip, and we get pi times 2 over pi. The pi's cancel out, leaving 2. $32. That's in the wrong spot. 32. The function g is given by, okay, this right here. So this says there is a period shift here from our normal parent function. Which of the following statements about the graph of g in the xy plane is true? So the vertical asymptotes of the graph occur at the input values. Okay, well, first of all, let's figure out what the vertical asymptotes are going to be. So tangent is undefined. When the denominator is 0. The denominator, so tangent is sine over cosine. So it's undefined when cosine of theta equals 0. Now, cosine of theta equals 0, so we need to figure out when does this equal 0. And that is going to be at 0 works, right? Tangent, no, sine over, no, at pi over 2. This is typically pi over 2 and 3 pi over 2. So we need to figure out when tangent, let me get on my paper. So we need to find out when tangent of theta, no, we need to figure out when, tangent of theta, sorry, how did I word this? Tangent of theta is undefined when cosine is equal to 0, and that's it. So we need to find out when cosine of 2 pi over 3, so that we can rewrite this as, start over real quick. Tangent of 2 pi theta is exactly the same as sine of 2 pi theta divided by cosine of 2 pi theta, and this is undefined when cosine of 2 pi theta is equal to 0. So if I take inverse cosine of both sides, I will have case 1, where 2 pi theta is equal to, well, cosine is equal to 0 at pi over 2 plus 2 pi k. And then I would divide both sides by 2 pi, or multiply both sides by 1 over 2 pi, which would give me theta is equal to, this 2 pi would cancel out, leaving just k, 1k, and I would, so this pi would cancel out that pi, so it should be 1 over 4 plus k. I really hope that's going to be an answer. We'll find out. Really weird thing to look at. Typically not a standard answer, but that's what the math worked out to be. Then case 2 is the other time, and that is going to happen at 3 pi over 2. So we get 2 pi theta, or shortcut, tangent is pi, let's just do this way. 2 pi theta equals 3 pi over 2 plus 2 pi k. Multiply both sides by 1 over 2 pi. And so that 2 pi cancels out that 2 pi, leaving k. And this pi cancels out that pi, leaving 3/4 plus k. So these are the two situations. We can end up, so this is, if you think about this here, there are this spot and this spot. These were pi apart. So k is a full lap, we only want half a lap because tangent is half the period of. We can actually cut this down into one equation by dividing this period by 2, since tangent is half the period of cosine. So this, hopefully, is an answer. Let's find out. The vertical asymptotes of the graph occur, at 0. Nope, 1 does not occur at 0. At 1/4, yay, 1/2 k. Yep, that's k over 2, so that is actually the exact equation we got. Hooray. 1/4 plus k. We got that equation, and then we manipulated it, so maybe. And then definitely not this one. We didn't get that one at all. But it definitely should be B. This one only gets half of the asymptotes. This gets both sets of asymptotes. Okay. 33. The graph of the function g is given in the xy plane. Great. If g is the result of a multiplicative and additive transformations, so this is a fancy way of saying a stretch and a compress. No, not stretch. A stretch and a shift of the graph tangent y, because what is the period of g? So the function of g, that's the graph of g, as a result of multiplicative and stretch of tangent. What is the period of g? I mean, it's just, you just got to figure out the period. So there is a turning point. Here is a turning point. So from 0 to pi over 4 is one period. So pi over 4 minus 0 should be pi over 4. That seems really easy. I'm going to pause it and check the answer key to make sure I did not overlook anything. That felt way, way too easy. 1 second. Okay, here is the answer key, and it's just pi over 4. Sweet. Easy peasy. Well, let's check again. I know that it looked like I went really, really quick, but that's the magic of editing. I've been actually gone for 7 hours. No, that's not true. It's just a couple minutes. Okay. The xy plane, an angle theta in standard position, has a measure of pi over, so theta equals pi over 3. So we have pi over 3. Great. I have an angle that is pi over 3. That's all it tells me. Which of the following is true? The slope of the terminal ray. Oh, so it wants us to figure out slope. Slope is tangent. So it's pretty much asking us, what is the tangent of pi over 3? Our tangent values are going to be 0. This one is going to be pi over 6 is root 3 over 3. It's 1/3 of root 3, which is smaller. I'll show you this in a minute. This one is 1, and this value is root 3. So it should be the square root of 3. Tangent is slope. And again, this is a steeper slope. It should be a bigger number. Okay? The square root of 3 is bigger than 1. And the square root of 3 is 3 times bigger than the square root of 3 divided by 3. This is 1/3 root 3. This is all of root 3. So this is the larger one. So it should be the steeper slope. Okay, let's go to 35. Yeah, we can do one more page. We got time in this video. 35, which the graph of the function h is given by the xy plane, yada, yada, yada. If the function is this right here, where a and b are constants, so a and b are just some number, which of the following is true? Okay, so according to this, a A changes amplitude. It's some horizontal stretch. If A is, here we do this. If A is bigger than 0, then it's just a regular tangent graph, regular tangent. And if B is greater than 1, so if B is greater than 1, that means B is a large number. And if B is a large number, it should be compressed. Okay, so it should be compressed, which means that the asymptote, if we're compressing it, these asymptotes would go in. So if it is, the asymptote would have to be less than its regular asymptote, which is usually at pi over 2. This asymptote is definitely less than pi over 2. So pi over 2 is right here. This is less than pi over 2. So there has been a compression. So B has to be greater than 1 because there is a compression. So that's this one. B is greater than 1. So we don't, that's the only, this one right here. These two. B has to be greater than 1. Now, the next part is if A is greater than 0, that is a regular tangent. This is a regular tangent that is stretched, so we don't want that one. That one's stretched as well. So we should know, is A bigger than 0 or smaller than 0? Is A positive or negative? Well, if A is positive, it should be the standard tangent graph. If A is negative, it flips it. It would reflect it upside down. This is an always increasing graph, so it should be a regular tangent graph that has been compressed. It has not been flipped. This one would be flipped. 36. The function f is given by a tangent of bx, so that is our, not really amplitude, but that is our vertical stretch, because tangent doesn't have amplitude, but yeah, same thing. Then b is our period shift, where a and b are constants, which of the following statements is true about the period. So our period for tangent should be pi over b. Both the value of a and b have an impact on the period. Well, that's not true. The period is only affected by that number right there. So it can't be a. Only the value of a has an impact. Nope. Only the value of b has an impact on the period. Yep. Neither value impacts the period. That is definitely not true. So that one has to be C. The function g is given by tangent of x. What are all the solutions to g of x equals 3? So that tells me that tangent of x is equal to 3. So in order to get x by itself, I just take inverse tangent of both sides. When I do that, I get the inverse tangent of 3 plus pi k, and I have to say pi k because the period is pi for tangent. So let's see. X equals arctan is the same as inverse tangent. Yep. What are all the solutions to x equals 3? So our arctans only, that's not true. That's no 2 plus pi k. That's no k. There's no k. So it's not that one. So it can't be A or B because this is only 2 solutions. We want all solutions. So it can't be A or B. X equals pi k plus arctan. So they just rearranged it because they're being cheeky. But arctan plus pi k, that's going to be D. That period is too big. Okay, I'll see you guys in the next video. Video 7 starts here.